All right, next up we have Joaquin Escobar-Dodero. Joaquin is a second-year PhD student in the veterinary medicine program at the University of Minnesota's College of Veterinary Medicine. He holds a veterinary medicine degree from Andreas Bello University in Chile. After completing his veterinary degree, Joaquin worked for an epidemiological consulting firm evaluating control strategies for key infectious diseases in the Chilean salmon farming industry. The primary focus of his PhD research involves the epidemiology of infectious diseases in aquaculture settings, focusing on bacterial disease dynamics in open sea fish farms. His research interests also include the biogeography of aquatic diseases and how landscape and macroecological features shape the distribution and spread of disease. So you can take it away, Joaquin.
Thank you for the introduction. Hi, everyone. So my presentation today is like trying to understand what is the potential effect of like how farms distribution across the seascape affect like the mortality of salmon rickettsial syndrome in the Chilean salmon industry. So like as an outline, we're gonna talk a little bit about how the Chilean salmon farming is about, like the objective of our study, how we get our hands into manage and do the proper analysis, the results, and some summaries of future steps. So as all of you may know, like aquaculture have been having like a quite important expansion in terms of productions since the last couple of decades. Some years ago, this surpassed the beef industry, but still is quite below what is the pork and poultry production worldwide. Considering this, most of the production, the aquaculture production, is still dominated by the freshwater systems. Marine systems only account for 20% of edible output. So, and one of these problems, or one of the reasons why the marine systems are quite low compared to the freshwater ones, is due to the logistical constraints of having farms in the sea, regarding like supply chain, infectious diseases, like environmental issues. So and in here we have in Chile, okay, we are one of the top salmon producers in the world, behind Norway. In 2017, we produced almost 600,000 tons of salmon, primarily 3 species. And if we look at the in terms of the production quantity, salmon is still behind what is a catfish, tilapia, and carp, which is probably which are the most farm species, like predominantly in Asia, China, India. But in terms of value, salmon is still like a really important commodity in the fish market. So basically here in Chile, we have this issue, like we have a really quite important industry, and also we have all these issues regarding like these constraints of marine farming, especially infectious diseases in the case of Chile. In Chile, we produce Atlantic salmon, Pacific or coho salmon, and rainbow trout, but predominantly Atlantic salmon accounts for nearly 70% of the production nowadays. So in Chile, we have here in the southern part of Chile, we have like the main regions are the 10th region and the 11th region in the Chilean administrative level, and we have these neighborhood separations, which are basically like logistical administrative areas which are basically the basic importance of this is like the following period between like the farm period. So So as you may know, like we have the freshwater stage specifically for Atlantic salmon, and then we move them to the marine stage for the grow out phase. In this phase, usually fish, depending on the species, are uh, approximately between 10 months up to 30 months, depending on the production strategy, the feeding um, strategy, and the market for sure. So one of our issues in Chilean industry is like infectious diseases. Uh, in 20% of total mortalities or total losses are due to infectious diseases. And within this category, salmon rickettsial syndrome, which is caused by P. rickettsia salmonis, is by far the most important one and prevalent. So when we account all the infectious disease mortalities, SRS account for approximately 70% of all these mortalities. So this disease basically is like the disease that we have to deal with in Chile, and the economic impact that we have is severe in terms of losses, and also because of all the prevention strategy that we have to use to deal with this disease, specifically vaccine. So the objective of my study here is like to evaluate how the contact pattern between infected farms can affect, like first evaluate how these infected farms can contact between each other, assess how is the spatiotemporal relation between them, and estimate like association between how infected farm can increase or induce SRS mortality among farms. So in Chile, we have like this, national audit system, which is comprised by several modules, like in which each farm have to submit weekly data to the government. And this data is mostly health and sanitary data, which is concerning like mortality, like what is the weight, like the number of individual, or estimate number of individual, the number of treatment, sea lice, and all other events that may happen in a marine phase, algae blooms, predation. And so we collected this data from the most important region, the 10th and 11th, from 2012 and 2017. Um, Active farms were excluded for our analysis, and also abnormal cycles were excluded, especially the ones regarding algae bloom, which is from time to time affect some farms in Chile and basically basically destroy whole farms. And also abnormal cycles, which mostly due to short duration because a specific market strategy from specific companies. So basically we gather farm information by cage and considering demographic, mortalities, parasites, sea lice, and locations, and we have to assign each farm a unique identifier due to the time span of our analysis. Like some farms after their following period are stocked again with fish, so we have to separate these farm as different individuals for the future analysis. As we can see here, like usually in Chile, we have this 6-month following period between harvest and restocking. And I forgot to mention that in Chile, we have this a lean allowed system. So once the farm is stocked with salmon species, there is no possibility of stocking new individual until the period ends. So because we have access to a huge amount of information, we have to do all the validation assessment. So, and specifically for this analysis, we did like a spatial assessment, try to understand how farms, like first analyzing all the location of farms, and also assessing what is the sea distance between them. So here we see like from this farm, we can estimate the sea distance, avoiding geographical accidents from all the other nearby farms. In this case, I only show you this close-up version, but in the full analysis, we estimate the distance from one farm to all the other farms in specific regions. So here in this case, we see like this blue path represent farms that are within 5 kilometers. And the purple one represents a farm that is far away, beyond 5 kilometers. So we use the shortest path approach to estimate this. We calculate the number of contacts per week that one farm can have with other infected farm, and also in order to assess if there is a spatial temporal association between infected farm, we run an Oxted to test that. And in terms to analyze like how is the risk or of having more or increased SRS mortality, we use a longitudinal retrospective approach in which we consolidate our data monthly. Our outcome was like an increased SRS mortality beyond 0.01% weekly, monthly. And we tested against demographic, environmental, and health predictor. Demographic in terms of the farm population, environmental regarding like the season, like which is correlated with the temperature of the water, and other health predictor in terms of sea lice, principally. And for this analysis, and due to our outcome, we use a generalized equation estimation, generalized estimation equation approach in order to assess how is this association in. So in Chile, we have like the farms we can see here are evenly distributed in these regions. Both in region, the mean distance between one farm to all the other is approximately 97 kilometers. And so basically are pretty much similar between the regions. And we grab our data from almost 1,300 farms, considering all 3 species. And once the idea is for us to analyze only Atlantic salmon farms in this specific analysis, so we subset our data to 640 Atlantic salmon farm across both regions. So when we analyze like the SRS, like salmon rickettsial syndrome, we see like one species is above all more affected by this one, which is a rainbow trout, and the evidence, like the past evidence, have shown that. Atlantic salmon salar, seems to be affected somehow. So some farms are quite affected, like have a huge number of mortality in overall for the whole farm process or the production cycle, but some other farms have near zero mortality. So when we analyze the temporal dynamic of this disease, we see while we assess the number of farms that have SRS cases across the whole study period, we see like after getting rid of these tails, because they account for in these areas farms that were active before or after the study period were eliminated. So if we notice in this area, we have like a fairly continuous number of infected farm always in our scenario in the industry. So basically it's because this disease is highly endemic and is present almost everywhere. So when we analyze how is the dynamic from different species, we see like rainbow trout have high number of mortality, is highly susceptible for this disease, but other species like Atlantic salmon here in green and Pacific salmon here in red are not really that affected. So one of the ideas is like rainbow trout can act like a spreader of this disease, like maintain the disease in the seascape. So when we analyze the spatial dynamic over time, here we selected like a specific time period, like cumulative week 200. We see like the SRS cases spread among both regions, like and so in red we have the Atlantic salmon, and in blue we have other salmonids, rainbow trout. So when we see how this change across week 200, 205, and 210, we see that we can see the SRS cases kind of group in some specific areas. So they are grouped in some specific number of nearby farms. And so the idea of this is have to test how this change the mortality of each farm regarding their neighbors. So when we analyze the infected number of farms at 5 kilometers, we see like over the course of the production cycle, we have a long, like a fairly a small but still constant number of farms having at least less than between 10 weekly contact with other farms in some cases. Some cases have less. So that makes us think that in some specific farms, they will have more mortality due to the reason of having more infected farms. So when we test how this dynamic kind of exists is like we gather like the weekly events, we estimate different spatial and temporal critical distance. We use a Monte Carlo approach in this case, and we apply a specific filtering approach in order to avoid contact interaction between same farms in different weeks. And we are noticed like even in a small threshold, 5 kilometers and 2 weeks, we see like the observed number of interactions are far above what we expect under the null hypothesis. So there is interactions within this disease among nearby farms. We also see that in a longer threshold for 15 kilometers and 6 weeks, but so also we see that in both 10th and 11th region. So when we analyze our longitudinal assessment of this disease, we see like when we have increased number of infected farms nearby, the risk of we having like a monthly outcome of a high burden of disease is associated with the number with the number of farms, infected nearby farms. But also when we analyze how is the effect of sea lice, which the evidence show that is highly correlated with due to like a co-infections pattern to the rise of SRS outbreaks amongst farms, we see like it plays a key role also, even more important than the number of infected farms close by. So both of these effects play a kind of pivotal role in shaping how like a farm can have a like different type of or increased number of salmon rickettsial syndrome outbreaks. When we analyze the farm population due to the possibility of farms having different kind of population, we see that there is no relation with that. Like smaller farms or like bigger farms doesn't seem to have like a special kind of relation between how these outbreaks occurred. When we analyze the seasonality effect of this disease, we can see that winter compared to fall decrease dramatically the risk of experiencing this outbreak. And this is also what we can find in the literature, saying that because of this is a bacterial disease, the occurrence of cases and furthermore outbreaks decrease during winter. But also one interesting point is like when we analyze the slope, like the change of the number, like the change of the number of infected farms across time, we see there is no there is no association with this, and this might be due to the possibility that each farm have at some point high number of infected farms nearby, and later on, this number of infected farms decreased because of farms are harvest or they are treated, or and the same applies to the sea lice count, or like the number of sea lice burden in farms due to this sea lice, due to treatment, are usually quite cyclic in their behavior. So the main idea of this, the main results are like SRS is highly endemic in our country, in our production system, but it occurs evenly across these different regions. Sea lice is highly associated with, or it is associated with higher presence of SRS. And the presence of neighboring infected farms can enhance the occurrence of these SRS mortality events. And the interesting thing is, like, we still see like the seasonality effect that have been addressed several times before in several analyses. Um, and and the other point is like this, even though these effects, like the nearby farms, the nearby infected farm and the caligos, is like they are quite cyclic. So the assessment of this co-infection pattern, or like this sea lice co-infection pattern and the nearby farms, are quite complicated in terms of properly analyzing them in what is the proper effect. And the future step is like, the idea of this is try to evaluate temperature in a more detailed way, considering real temperature data, which is complicated to get from the salmon industry, from the government data. And also the idea is to account for treatment across time. In this case, we selected or we try to select farms that have similar type of treatments across time. But that's one of the big caveats of this analysis, is like, even though we try to normalize the way treatments occur across farm, we have to deal with this in a more proper way in the modeling approach. So with all that said, like, I'm happy to have questions. Thanks.
All right, thank you, Joaquin. Great talk. Open it up to Q&A. If people have anything they'd like to ask, just go ahead and unmute yourself or put it in the chat box.
Hey, Joaquin, nice job on the presentation. This is Jan Levy over in New Jersey. How are you?
Good, thanks.
Good. I'm curious about the spatial proximity that you use in the model. Ocean currents can definitely have a big effect on how things spread out there. I noticed you use the 5-kilometer proximity. Is there any way to build into the model ocean currents and things, the way that things are moving in the ocean that way?
Yeah, we try to get like the data regarding ocean currents. Unfortunately, given the highly spread, like it's basically due to the geographic pattern of the Chilean coast. Like specifically, we can see here in the, we can see here, because in this area, as far as my knowledge goes, and what I get from the salmon industry, is like currents are quite difficult to assess in here. And the data is not really like available in all farms. And yeah, that's unfortunate. I understand, like in some other in some other cases, specifically in Norway, they are using currents, like hydrological models, in order to assess like how is the effective movement of currents. However, in our case, it's highly complicated to get. But that's why we choose like really narrow spatial threshold in order to account by in order to try to mimic like this kind of current movement, like to be more effective and more like more realistic in some way.
Okay. Thanks.
Thanks you.
I'll ask another question if no one else is out there.
Okay.
It's interesting with the sea lice, and potentially sea lice are another stressor in that fish population, and maybe that's why you're seeing more rickettsia in there. But is there any information on rickettsia being spread by sea lice? Like if a sea lice feeds on a fish, can it actually be a reservoir for Rickettsia?
There have been some anecdotal evidence of that, like me interviewing farmers. They usually have this kind of rule that once they start seeing high number of sea lice, they start, because they have like this kind of management area. So once sea lice start occurring in one farm, is quite, and because it's a parasite, it can move easier compared to bacteria at some point. It spread quite easily among the management area. And once they start seeing this kind of high number of sea lice across this area, they start seeing SRS. But a specific assessment of how the possibility of sea lice or a specific sea lice is stages kind of transmits Rickettsia, there haven't been like a specific assessment. And so yeah, that's a complicated thing in our industry. Like we have this kind of knowledge gap that are quite difficult for us to kind of build like the whole world of how this disease moves.
Sure.
All right, any other questions for Joaquin out there?
Hey Joaquin, this is Jan again. Since it's a little quiet out there right now. Out in the Pacific Northwest in Canada, where they do a lot of Atlantic salmon culture, this disease is out there as well, but it seems to have pretty minimal impacts. Now, compared to the Chilean situation, is it environmental differences that you think we're seeing between Chilean raised Atlantic salmon versus the ones raised out in Canada?
Yeah, that's quite interesting, because like this disease, Salmonella syndrome, was first documented in Chile in 1989. But further assessment have found this disease in Canada, like in this New Brunswick area. And not really sure if in the U.S. main area have found this disease, but in Norway they have found these diseases. So they have found this bacteria across different areas, but in our context, we have like a really big issue with this, and like currently there is no explanation on why this happened. Some people might are saying like this kind of evolutionary pressure for this bacteria to have like a big susceptible population, with like in previous law of the infectious salmon anemia outbreak in 2007 that decimated our industry. The culture and practice were quite lax in terms of the number of fish that you can pull, like all the biosafety measures. So one guess is like this bacteria in our area is more pathogenic because of all these evolutionary pressures, but also assessment between the like some genomic patterns of virulence between isolates from Chile and from other area haven't shown like really specific kind of conclusion about what makes our bacteria more virulent, or our strains more virulent from what we see in Canada. So yeah, that's really interesting to see what is happening there.
Yeah, cool. Very interesting. All right, thanks a lot. Good
Okay,
job.
thanks you.
Anything else, Jan? Good.
I'm good.
All righty. Anybody else have a final question for Joaquin?
I'll help Jan out a little bit. Hey, Joaquin, this is Alex Primus from University of Minnesota.
Hi, Alex.
Hey, very nice presentation. I think we talked about this a little in the past. I forget what the answer was, though. Did you incorporate in these models any protective effect of vaccines in any way, or was that just too difficult?
Yeah, well, the thing is that that will be really interesting to put it in like directly in the model, but there is no vaccine information from these from all specific farm, and that's what one of the reasons that we choose to use only Atlantic salmon as the study, like the species study, because due to the health normative in Chile, all Atlantic salmon individuals that are put into sea have to have the infectious salmon anemia vaccine. And due to kind of marketing or like production strategies, they use this pentavalent vaccine. So accounts from the producers, they say that 100% of the salmon are vaccinated against infectious salmon anemia, but also against salmon rickettsial syndrome. The thing is that they use different vaccines, and that's quite interesting. It wasn't that interesting some years before because we used the same vaccine. But maybe 2 to 3 years ago, they have like this live vaccine. So yeah, that might make some noise, and we are working up to get like more specific data on the vaccine, at least the type of vaccine, in order for we can account for that confounder. Bye.
Okay, thanks.
Okay, thanks, Alex.
Great. Well, thanks again, Joaquin. Virtual round of applause for you and Ethan for a couple of great talks today. Really appreciate your participation, and everybody who was watching this week for the online seminar. We've got 2 talks next week, one from the University of Idaho and one from Michigan State University. So I encourage you to sign back into that and share the link with other people who might be interested a week from today. All right, have a great weekend, everybody.